Astronauts from the Artemis II moon mission recently witnessed a significant engine test that will propel future lunar endeavors, including the Artemis program's ambitious goals. Commander Reed Wiseman, alongside crewmate Christina Koch, observed the test of the RS-25 engine at NASA's Stennis Space Center in Mississippi on March 6. The dramatic 10-minute test, captured on video, aims to validate the engine's capability for upcoming Artemis missions to the Moon and beyond. The RS-25 engine, a veteran of the Space Shuttle program, will power future versions of the Space Launch System (SLS) rocket. This engine type was previously used on the uncrewed Artemis I mission in 2022 and will be utilized again for Artemis II. Slated to launch for astronauts around the Moon in 2025. However, Artemis V and subsequent missions will utilize new variants of the RS-25 with increased thrust. To certify these engines, NASA is conducting a series of 12 tests in 2024, employing innovative manufacturing techniques. The March 6 test, the ninth in the series, involved firing the engine for 10 minutes, longer than the typical duration required for launching the SLS rocket and sending astronauts aboard the Orion spacecraft into orbit. During the test, engineers examined engine performance at power levels ranging from 80% to 113%, evaluating its effectiveness in various scenarios. The Artemis II crew, comprising Wiseman, Koch, NASA pilot Victor Glover, and Canadian Space Agency mission specialist Jeremy Hansen, eagerly observed the proceedings. Artemis II and its successor, Artemis III, faced delays earlier this year due to technical challenges, with Artemis II rescheduled for September 2025 and Artemis III for September 2026. While the Artemis III crew has yet to be announced by NASA, all Artemis missions aim to advance the program's ambitious objectives, including establishing a sustainable human presence near the Moon's south pole, where water ice resources are abundant. The Artemis program is guided by the NASA-led Artemis Accords, which have garnered 35 signatories committed to peaceful space exploration. Several countries participating in the Accords contribute hardware to Artemis in exchange for mission opportunities, enhancing international collaboration in space exploration. The inaugural flight of Japan's privately developed Kairos rocket ended in disaster just moments after liftoff on March 12. The rocket, constructed by the Japanese company SpaceOne, exploded approximately 5 seconds after leaving the launch pad. Eastern time from Spaceport Key, located in the southern part of Honshu. Video footage of the launch revealed that the rocket had not yet cleared the surrounding hillside when it exploded, sending debris falling back to the ground near the launch site. Fortunately, there were no reports of injuries, and the launch pad itself seemed to have escaped any significant damage. The cause of the explosion was not immediately apparent. The Kairos rocket utilizes 3 solid propellant lower stages and a liquid propellant upper stage. SpaceOne issued a brief statement suggesting that the rocket's flight termination system had been activated, but did not provide further explanation. Originally scheduled for March 9, the launch had been postponed twice before due to issues including an aborted countdown and a delay caused by a ship in restricted waters offshore. Kairos was designed to cater to the small satellite market, boasting a payload capacity of 150 kg to sun-synchronous orbits and 250 kg to an orbit inclined at 33 degrees. The mission's payload for this launch was an experimental satellite intended to test responsive space capabilities for the Japanese military. SpaceOne, established in 2018, counts Canon Electronics, IHI Aerospace, and the Development Bank of Japan among its shareholders. Each shareholder contributes specific expertise, with Canon specializing in mass production of electronics and IHI Aerospace having a background in rocket development. Kairos was marketed as Japan's first privately supported orbital launch vehicle, distinct from those backed by the Japanese space agency JAXA. SpaceOne aims to increase production of the rocket to accommodate up to 20 launches annually, although details regarding customers remain scarce. StarShip's third launch reaches space, but lost during re-entry. The latest flight of StarShip, the world's mightiest rocket, took off from Texas and soared beyond 230 kilometers above Earth, marking its farthest and swiftest journey to date. However, upon re-entry into Earth's atmosphere, the spacecraft appears to have met a catastrophic fate. SpaceX's third and most ambitious Starship test flight seemed to achieve significant milestones, including successful fuel transfer tests and unprecedented distance and speed records. Nonetheless, the spacecraft failed to execute its planned landing and seems to have either self-destructed or burned up during re-entry. Following liftoff from SpaceX's Boca Chica site in Texas, the initial and secondary stages separated smoothly. The first stage, responsible for propelling the craft initially, attempted a controlled descent for a sea landing. While efforts are made to recover and reuse both stages, during these initial test flights, they are intentionally directed to the ocean for a safer landing. Although the first stage managed its descent, it struggled to decelerate as expected, resulting in a high-speed impact with the sea. Meanwhile, the second stage ascended to approximately 230 kilometers, where it successfully tested its payload door operations and fuel transfer mechanisms, an essential step toward refueling Starships during long-range missions. However, as the craft re-entered Earth's atmosphere, it encountered extreme temperatures, evident from live footage displaying glowing plasma around its surface. Unfortunately, both video and telemetry data were lost during this critical phase. Originally, the plan included relighting the Raptor engines, never attempted in space before, for a controlled descent at nearly 27,000 km per hour. However, SpaceX opted out of this maneuver, leading to the craft's demise. The U.S. Federal Aviation Administration granted permission for the test flight, emphasizing SpaceX's compliance with safety, environmental, and financial standards. Starship stands as the most formidable rocket ever constructed, boasting a length of 121 meters comprising two stages, a booster and a spacecraft, both designed for reusability to lower costs and enable rapid flight turnovers. This launch marks SpaceX's third attempt with Starship. The previous tests, conducted in April and November of the prior year, encountered mishaps, including explosions and data transmission failures. Nonetheless, the overarching objective remains unchanged: to facilitate human missions to the Moon and, eventually, Mars. Rocket Lab successfully launched a radar imaging satellite for the Japanese company SynSpective on March 12, marking another milestone in their ongoing collaboration. The launch took place from Rocket Lab's Launch Complex 1 in New Zealand, with liftoff occurring at 11:03 a.m. Eastern Time. Delays due to weather pushed the launch 3 days past its original schedule, and it occurred at the tail end of the day's launch window, which lasted approximately 75 minutes. The rocket deployed the STREX-3 satellite into a sun-synchronous orbit approximately 54 minutes after liftoff. This mission marked the fourth Electron launch for SynSpective, which is building a constellation of synthetic aperture radar (SAR) imaging satellites. Previous SynSpective satellites were launched aboard Electron missions in December 2020, February 2022, and September 2022. SynSpective has secured over $200 million in funding to deploy its SAR satellite constellation, including a $100 million Series B funding round in March 2022. The company aims to have 30 satellites in orbit by 2026. STREX-3 is the fourth SynSpective satellite launch to date, all aboard Rocket Lab's Electron rockets. A multi-launch agreement between the two companies, announced in July 2023, includes 2 additional Electron launches. Dubbed All Night Long by Rocket Lab, this launch marked the 45th overall Electron launch and the third mission of the year. Another Electron mission, for the National Reconnaissance Office, is scheduled for no earlier than March 20th from Rocket Lab's Launch Complex 2 site at Wallops Island, Virginia. During Rocket Lab's earnings call on February 27, Adam Spice, the company's chief financial officer, revealed plans for 22 Electron launches in 2024, up from 10 launches in the previous year. Among these launches, 2 are for the suborbital version called HASTE, which command higher selling prices but also incur higher costs due to range fees and mission assurance requirements. NASA's SpaceX Crew-7 successfully concluded its 7th commercial crew rotation mission to the International Space Station, touching down safely in a Dragon spacecraft off the coast of Pensacola, Florida, on Tuesday. The multinational crew of 4, comprising NASA astronaut Jasmine Mobelli, ESA, European Space Agency, astronaut Andreas Mogensen, JAXA, Japan Aerospace Exploration Agency, astronaut Satoshi Furukawa, and Roscosmos cosmonaut Konstantin Borisov, spent a total of 199 days in orbit. The crew splashed down at 5:47 a.m. Eastern Daylight Time, and teams aboard SpaceX recovery vessels promptly retrieved the spacecraft and its crew. Upon their return to shore, the crew will travel to NASA's Johnson Space Center in Houston. NASA SpaceX Crew-7 has safely returned home after more than 6 months aboard the International Space Station, remarked NASA Administrator Bill Nelson. This international crew demonstrated that space brings us together. Collaborative efforts like these enable us to achieve more and acquire greater knowledge. The scientific experiments conducted during their mission will contribute to NASA's ambitious missions to the Moon, Mars, and beyond, while also benefiting humanity on Earth. The Crew-7 mission commenced on August 26, 2023, with liftoff at 3:27 a.m. aboard a Falcon 9 rocket from NASA's Kennedy Space Center in Florida. Approximately 30 hours later, the Dragon spacecraft docked to the Harmony module space-facing port. The crew undocked at 11:20 a.m. on Monday, March 11, initiating their journey back to Earth. During their mission, Mobelli, Mogensen, Furukawa, and Borisov spent 197 days aboard the space station and completed 3,184 orbits around Earth. Notably, it was the first spaceflight for Mobelli and Borisov. Mogensen has accumulated 209 days in space across 2 flights, while Furukawa has logged 366 days in space over 2 flights. Throughout their mission, the Crew-7 members conducted numerous scientific experiments, maintenance activities, and technology demonstrations. Mobelli participated in a spacewalk alongside NASA astronaut Laurel O'Hara, during which they replaced one of the 12 trundle-bearing assemblies on the port Solar Alpha rotary joint, crucial for tracking the Sun and generating electricity to power the station. Additionally, the crew contributed to hundreds of experiments and technology demonstrations, including research on human response to varying spaceflight durations and experiments related to food cultivation in space. This mission marked the 3rd flight of the Dragon spacecraft, named Endurance, which previously supported the Crew-3 and Crew-5 missions. Following its return, the spacecraft will undergo inspection and processing at SpaceX's refurbishing facility at Cape Canaveral Space Force Station, where it will be prepared for its next flight. The Crew-7 flight is part of NASA's Commercial Crew Program, which aims to provide safe, reliable, and cost-effective transportation to and from the International Space Station and low Earth orbit. This initiative has already facilitated additional research opportunities and increased the potential for discoveries aboard humanity's microgravity testbed for exploration, aiding NASA in its preparations for human exploration of the Moon and Mars. NASA engineers are making progress in resolving the communication breakdown issue encountered by the Voyager-1 spacecraft, which currently resides outside the Solar System. An anomalous signal has provided crucial insight into the problem. Voyager-1 made history in 2012 by becoming the first human-made object to exit the Solar System and enter interstellar space. For 11 years thereafter, it transmitted valuable data to ground control, offering insights into the workings of space beyond the Sun's influence. However, in November 2023, Voyager-1's communications with Earth became unintelligible. It's important to note that Voyager-2, its sibling spacecraft, which departed the Solar System in 2018, continues to operate and communicate with Earth. The issue seems to stem from one of Voyager-1's onboard computers, the Flight Data Subsystem, FDS. This computer is responsible for preparing science and engineering data for transmission back to Earth. Encoded within the FDS memory are performance instructions, code values, and the data to be transmitted. Changes in the spacecraft status or commands can alter these stored values. To address the problem, engineers initiated a prompt, or poke, from Mission Control to Voyager-1. This prompted the FDS to attempt using different sequences in its software, potentially bypassing any corrupted or damaged sections causing the communication issue. Given Voyager-1's distance from Earth, around 15 billion miles, it takes approximately 22.5 hours for a radio signal to travel from the spacecraft to Earth and another 22.5 hours for a response. Therefore, decoding signals and analyzing data is a time-consuming endeavor. On March 3, the Voyager mission team detected unusual activity in one section of the FDS, indicating a potential breakthrough. Although the newly detected signal wasn't in the expected format, an engineer at NASA's Deep Space Network managed to decode it. The signal contained a readout of the FDS' entire memory, providing valuable information for troubleshooting. NASA scientists and engineers will continue their efforts to restore communication with Voyager-1, a pioneering mission that has expanded humanity's understanding of the cosmos. Despite the challenges, this positive development marks a significant step forward in resolving the communication issues between ground control and the spacecraft.